Oh, all right, we're on page 6 in your packet. 6 in your packet, Chapter 7 Notes, Part 2. Okay, page 6 in your packet. All right, what we want to talk about today is how well the data is correlated around the line. Okay, how well the data, all the individual pieces of points, are around the line. Okay, and so in a sense, you're thinking about how closely clustered these points are around the line. Okay, how closely clustered these points are around the line. Okay, so the correlation coefficient is this represented by this lowercase letter r. It is called the linear correlation coefficient because it measures the strength and the direction, meaning like positive or negative, of the linear relationship. And I'm stressing linear relationship because are there other kinds of relationships that we have in functions and such? Yes, what's another kind of relationship, do you know? Quadratic, exponential, other kinds of functions, logarithmic. Have you heard of those ones that you've done in your other math classes? So those are other kinds of functions, quadratic, okay? But this in particular, we're interested in the linear relationship. So we have, again, a measure of how clustered the data is around the line. It is represented again by this lowercase r. Now, the value that this r value, this correlation coefficient is, from a -1 to a +1. So they're basically all these decimal values, okay? If you, of course, point up to the right, then you have a positive. If you point down from the left, then you have a negative correlation. And I'm sure you've seen the no correlation ones. The no linear correlation ones are ones that, you know, just look like they don't really have much pattern going on. So that is your no linear correlation. And furthermore, this no linear correlation has an R value that is close to 0. So the more scatter there is and randomness to the situation, not a relationship, then your R value is closer to 0. All right, so let's take a look at some examples here. You can see this first one here has an R value close to 0 because there's pretty much nothing going on, no pattern happening there. Okay? This line that they have drawn through there could go anywhere. It could be a flat line as well. Okay? No linear correlation. Okay, this next one. This one has a correlation of 0.9. So it is positive, okay? And they're fairly closely clustered around the line. This next one has a correlation coefficient of 0.6. Do you see how these are a little bit more spread out than this one up here? See how these are closer around the line? And these ones are more spread out around the line. Okay. By the way, which one would you think would have a bigger standard deviation? This this first one here that has a R value, these are closer to the line, or this one here that they're more spread out. Which one would have a bigger standard deviation? More spread out. So we would have a bigger standard deviation because they are more spread out. Good job. Okay, finally, you would see if the correlation coefficient is a perfect 1, then that's whenever your points are all on the line. They are perfectly all on the line, a perfect straight line. Okay, next, a correlation. Okay, by the way, those go similarly in the negative direction. So if I had said a -1, then that would have been a perfect straight line in the negative direction. If I had said -0.6, they would have been spread out in the negative direction. Okay, so a -0.6. A -0.9 would be closer to the line in the negative direction. Okay, so they mirror the positives. I want you to keep in mind, again, and I've stressed this more than once, R is a measure of linearity. R is a measure of linearity. So it is appropriate to talk about the correlation coefficient with this first set of data because that's linear. It is not appropriate. So do not talk about the R value with this second set of data because that's obviously some other kind of relationship that's not linear. This one looks more something that is what? What kind of relationship does that one look? Yeah, it says curvilinear, but I mean, what do we know? Quadratic, because it kind of looks like, good. Yeah, okay, you may have said it and I didn't hear you. It looks more quadratic, okay, because we've got some kind of parabola happening there. And so it is not appropriate to talk about the correlation coefficient with that kind of data. All right, moving on. So now, we have a saying that we need to have memorized, just like how we had our slope saying memorized and our interpret the y-intercept saying memorized, okay? Y'all want to? There is a song, of course, for this, all right? So, the first thing that we want to talk about is the strength. We want to talk about the strength of the relationship between the two variables. Is there weak, fairly strong, strong, moderate, those kinds of things. And I have a guideline for which you kind of need to memorize. So let's think about these. All right? You know, the closer you are to 0, the less linear relationship there is. So 0 is no linear relationship to 1 being a perfect linear relationship. So look at these numbers. See if they kind of make sense to you. 0.0 to 0.3 is no linear relationship to weak. 0.0 to 0.3, that's weak linear relationship, okay? Weak, very weak, all those kinds of words. Well, look, 0.4 to 0.6, aren't those numbers kind of in the middle? They center around 0.5. So that's moderate, okay? So 0.4s to 0.6s would be moderately strong, okay? In the middle. 0.7s to 0.9s, we're getting close to 1, so we are now getting stronger linear relationship. So I would use the terms, if you have a 0.7 to 0.9, I would use strongs and very strong. Okay? And then, of course, if it's a 1, which never happens in real life, is a perfect linear relationship. So, we first talk about the strength, and that has to do with the number value. And then we talk about if it's a positive or negative, so the direction. Okay? Linear relationship, this word linear relationship has to be in there between the context, whatever x is, and whatever y is. Okay, so there is a strong or weak, positive or negative linear relationship between your x variable and your y variable. And of course, you would use words when you describe your x variable and your y variable. So, here comes the song. Let's see here. It goes to Blue Suede Shoes. Do y'all know Dylan Zadaran? You remember him from a couple years ago and his sister Taylor? I love Dylan. Well, he even has like a little dance to go with it. So we'll see how this goes. Maybe I'll show you the little dance, okay, if I can remember it. All right, here we go. So here is your correlation coefficient. Look, there is a strong or there is a weak. Okay, so that's how strong it is. Positive or negative linear correlation between x and y. Linear between x and y. Okay, so here's how this one goes. There is a strong, there is a weak, positive or negative linear correlation between x and y. Linear between x and y. Okay, you guys sing along. Here we go. There is a strong, there is a weak, positive or negative linear correlation between x and y. Linear between x and y. All right. Okay, so let's see how that goes. So here we go. We're going to practice writing that out. Here we go. The following represents the data for the price of a pumpkin and the diameter in inches. So first, I want to know, what do you think is the explanatory variable if I talked about price of pumpkin and its diameter? What's explanatory? So the diameter is explaining the price? I agree. So therefore, The diameter is my x variable, and the price is going to be my y variable. Okay? It says R is 0.7. So let's say what that means. 0.7, what kind of strength is that? I wouldn't say very strong, because that's like when you're getting to the 0.9s, but strong. Okay? So here we go. There is a strong, there is a weak. Okay, so this case, there is a strong. Then what do we say next? Positive or negative? Linear. Okay, so what's we got here? Positive or negative? Okay, so there is a strong, positive or negative, linear. Okay, so don't forget that. Linear correlation or relationship between what? Good. Yep, and you don't just say between X and Y. Don't just say X and Y. Between diameter and price of the pumpkin. Linear between X and Y. So there is a strong, positive, linear correlation between diameter and price of the pumpkin. Okay? All right. So here is the next one. This is about the size of a, I don't know why it says graph farm. I've just never fixed that typo. The size of a farm and the price per pound that it charges its retail clients. For example, if you go to a specialty store, that's a small little boutique, versus going to Costco, okay? What's the price per, pound of things? Where is it going to be more expensive? The little boutique. Yeah, as you go to the Costco or the big stores, then the price is going down per pound. Okay, so this might be the same thing. Maybe small farms are specialty farms and they're charging more per pound, whereas big huge retail, big huge farms are just putting them through, and all those ones are going to Walmart, and those ones are $3 for a pumpkin, I don't know. Do you think the price per pound is telling you the size of the farm? Or do you think the size of the farm is explaining the price per pound? Good. So the size of the farm is my explanatory, and it is explaining the price per pound. Okay. Now this one shows a negative relationship. Do you see how spread out that data is around the line? Do you see how it's kind of pretty not real? Yeah, it's weak. It's negative 0.3. Do you see R is negative 0.3? So there is a what? Weak. Yep. And then direction? Negative. Okay. And then linear. Positive or negative? Linear. Okay, so that word has its own place in the song. Linear, so you don't forget it. Correlation or relationship, whichever word you choose to use. Correlation between X and Y. But I'm going to say between size of farm and price per pound. Okay, linear between X and Y. There is a strong, there is a weak, positive or negative, linear correlation between X and Y. Linear between X and Y. All right, so now we have those things here, and you're just going to practice. There's no context that you can see on these first 4 problems, so you get to actually use between X and Y. You don't have to put context in there. The next thing here, take you through this. So let me, I need to point out one particular thing that's really, really important, and that is, let's actually go to this number 5, because some of your calculators are not already putting in the R value when you calculate the equation of the line. So let's go here to this problem in your assignment and put this in your calculator, okay? So take a moment, go put this. When you calculate the equation of the line, the correlation coefficient should show up. But I guarantee probably on half of your calculators, it does not show up. So I'm going to tell you how to get it to do that. Let's go ahead. Let's check first. Do you know calculate the equation of your line? Okay, that's your stat over to calc number 4. Okay, and then calculate the equation of your line. Now look there, mine shows up. It gives you a, b, r squared, and r. Okay, so upon it not showing up, and I want you to write these steps down so you can always go back and reference them. To get r to show up, you have to turn the diagnostics on. That's what you have to do. To get R to show up, you have to turn the diagnostics on. Now, there are 2 ways that you can do that. I'm going to show you the easiest way, but it happens to only work on the newer calculators. So if you have one of the newer calculators, then you can simply, if you have one of the newer calculators, then your menu is all set up and it's super nice. So if you have a newer calculator, you can go to Mode, and you can go down and you press the Mode button, and then you go down and you turn your diagnostics on. So I'll show you what that looks like. So here we go. Mode is right there next to the second button. I do that and I just arrow down until I find the line that says Stat Diagnostics. So I'm looking for that line that says Stat Diagnostics. Okay, some of the old ones do have it too. I know some of my yellow ones have it and some of my yellow ones do not. So I'm turning my Stat Diagnostics on. All right, now you're set. If you go back and you recalculate, you are good to go. Okay, I need everybody though to learn this other way in case you get stuck with an old calculator. The other way is to go to the catalog in the calculator. So we're going to go to the catalog, oops, that's a Q. Catalog in the calculator, and the catalog in the calculator gives you everything in the entire calculator in alphabetical order. So if you ever can't find something, go to the catalog. And you know where that's located? Above 0. Do you see the number 0? Do you see the little blue words above it? It's catalog. So how do you get blue words? Second, and then 0. So if I hit second and then 0, it gives me an alphabetical list of the entire catalog. So I hit second, and then I hit 0. Now, I'm starting in the A's, but I have to go all the way down to the D's for diagnostics on. So that's kind of a long trek down there to that part of the alphabet. So if you happen to notice above this button, X to the -1, it has a letter D there, so it'll jump to the letters in that part of the alphabet. So I'm going to go down there and I'm going to do my little arrows until I get and find the words diagnostics on. I'm going to hit the button enter for diagnostics on. It's not done yet. You have to hit enter, and so it says done. So go to the D portion of the alphabet, diagnostics on, and then done. All right, so those are the 2 ways to get that R value to show up when you calculate the equation of the line, okay? So I just need you to have that there in case you need it. That's this thing called correlation coefficient. All right, so let me let you go and work on your assignment, which is pages 8 and 9. Okay, pages 8 and 9 are your assignment. I'd like for you to get that done in class right now.